So we will dip our toes into solving equations. And the equations that we solve today are all going to be linear equations. And so what does all that mean? If we're going to solve an equation is a statement that sets two expressions equal to each other. So if you've noticed so far, pretty much nothing that we've done has had equal signs in it at the start of the problem. So I can say something like x equals 5. Okay, well that's an equation because I've got the expression of x, then I've got the expression of 5, and I've set them equal to each other. So we are going to be dealing with linear equations, and you will get more involved with linear equations later, but for right now, remember that the first 4 letters spell line. So all of these make lines. And also please remember that all lines in math are straight. So when I say, oh, look at that pretty line, that's a curve. So lines can either be vertical, horizontal, or some method of diagonal, whatever. Okay. So how do I know that? I know from looking at a picture of a graph that it can be a line because it'll be a straight line. But how do I know from looking at the equation? The biggest exponent will be a 1. So remember that there is an x to the first right there, and I'm too lazy to write that exponent. So even this 5 has an exponent of 1. I'm just too lazy to write it. So the largest exponent will be a 1. The largest exponent on your variables. And we're not going to do any fractions in our exponents. We're not going to do any decimals in our exponents. And we're not going to do any negatives in our exponents. So really the only options that you have for an exponent in this section are 0 and 1. Okay, so I'll know it is linear based on the fact that the largest exponent I have is a 1. So when I go from here, what I also need to recognize is if I'm solving an equation, I am finding all of the values that can be used to make the original equation true. So on the first one that we go through and solve, I'm going to go backwards and I'm going to show you the substitution and all that kind of stuff to show how you would prove that it was true. But for right now, we're just going to say I'm going to solve all, or I'm going to find all the numbers that will make it true. And then what we want to do is go in and start solving. So my mission on this, I've got a 7x plus 6 equals an x minus a 3. Okay, so this equal sign is kind of like a fence. Okay, so that equal sign separates it into the left side and the right side. I can do anything I want to as long as I do it to both sides of the equation. So one of the first things I want you to notice is that the left side is already as simple as possible. I've got a variable term and I've got a constant term. And the right side is as simple as possible. I've got a variable term and I've got a constant term. So that's going to be my mission throughout this section, is I want to get it at least to this level. I may have to do a lot of organizing first, but if I can get it to this level where I've got variables plus numbers equals variables plus numbers, then I can solve it from there. So here's our strategy. We're going to move the smaller quantity of x's. So I've got 7 x's here, and I've got 1 x here. So what's the smaller quantity? The smaller quantity is 1. So the way I'm going to move it is I'm going to change its sign. So right now this is a positive x. I'm going to subtract x, and I can do it as long as I do it to both sides. So now look what happens. On the right side, I have an x minus an x means how many x's are on the right? No x's. And so that's actually going to equal just a -3. On the left side, I have 7 x's minus 1 x is how many x's? That leaves me with 6x's, and then I've got this plus 6. So now you'll notice by moving my smaller quantity of x's, I've kind of forced my x's to be on the left. Well, that's fine. That means we're going to put our constants on the other side. So since my variables are on the left, I'm going to get rid of this 6 now. So what is the opposite of adding 6? The opposite of adding 6 is subtracting 6. So I'm going to do that to both sides. So notice I can do whatever I want to, as long as I do it to both sides of the equation. So I have a 6 minus a 6 is nothing over here. So what's left is a 6x. And that's going to equal negative 3 minus 6. Your signs are the same, so add and keep the sign. Gives me a negative 9. So now I've got my x's almost by itself. I have 6 times x. So what's the opposite of multiplication? The opposite of multiplication is division. So to get rid of that 6, I'm going to divide both sides by 6. So any number divided by itself is 1. That leaves me with x equals, and now this is a fraction that I'm going to go ahead and reduce. So I can pull a 3 out of both of those. So that's a negative 3 times 3 over a 2 times 3. So any number divided by itself is 1. So that becomes negative 3 halves. Or 9 divided by 3 is 3. 6 divided by 3 is 2. Just divide the top and the bottom by the same number. So I just found out that the solution, out of an infinite number of numbers that are possible, I found one number that will make this original equation true. Okay, so this is why I said I'm just going to do this once. That's my answer. So I am going to rewrite this problem, and we're going to substitute in that negative 3 halves. So I have a 7x plus 6 equals an x minus 3, and we just found out that x is a negative 3 halves. So I'm going to check my work. So I have 7 times x plus 6 equals x minus 3. Well, what is x? X is negative 3 halves. Negative 3 halves. Okay, so for this part, I get a negative 21 halves. Plus 6 is negative 3 halves minus 3. So I need 2's. I need common denominators of 2's. So this has already got it. But I need this to have a 2. So what do I multiply top and bottom by? By 2. So that gives me a 12 over 2 equals negative 3 halves minus, and then I need that to be a 2. So multiply top and bottom by 2. So I get negative 6 halves. So now we're just going to combine like terms. So negative 21 plus 12 is going to be a negative 9 halves. And a negative 3 minus 6 is a negative 9 halves. So that works. You found the one missing number. You found the one number out of an infinite number that will make the left side equal the right side. So that's what you're finding. Now, one last thing. Let's go back a page. When I found this answer, technically, I need to put it in curly brackets. And curly brackets mean that my answer is listable. There's a small enough quantity that I can list it. So I've got a single solution, and that's listable. So the curly brackets are going to be given to you. I just didn't want you to be surprised when you see them. But it does mean that x is the solution set of negative 3 halves. Okay, and it just means that my solution set is listable. So now we have another type of equation. And so I'm going to start this off by saying x plus 1/10, and that's going to equal negative 1/5. So here's my dividing line, and I've got 3 terms. I've got 3 chunks going on. 1, 2, 3. And the first thing I see is fractions. I do not want to mess with fractions. I just don't. It is late and I'm tired. So let me ask you this. If I did get a common denominator, what would it be? It would be 10. So I'm going to take 10 times all three chunks. And I'm going to distribute using the distributive property. So remember, I can do anything I want to as long as I do it to the entire equation, which I am. So a 10 times a 10x, or sorry, times x is 10x, plus 10 times 1 is 10 over 10, equals 10 times negative 1 is negative 10 over 5. So look at this magic. What is 10 over 10? It is 1. What is negative 10 divided by 5? It is negative 2. So what I've done, I cleared the equation of fractions. And by doing that, it just makes life a little bit easier. So I can do this as long as there's an equal sign. If there's not an equal sign, that's why we haven't done it in the previous section. There has not been equal signs. So do not clear fractions if there's not an equal sign. Otherwise, you'll blow stuff up. So what I have now is my basic setup. I've got my variable term, plus or minus a number. My variable term's already gone over here on the right. So I'm already a step into where I wanted to be. So since my variable's on the left, I'm going to move everything else to the right. So I'm going to subtract 1 from both sides. So that gives me 10x equals negative 3. And then how do I kill the 10? Well, this says 10 times x. So do the opposite. So I get x equals, because any number divided by itself is, and then negative 3/10. That's your answer. Let's just see if we can reduce it. And we can't. So your answer is negative 3/10. Okay? And that, again, would technically be in curly brackets, but those are being given to you. So you don't have to worry about curly brackets. All right, so let's try it again. I've got a negative 3/4 plus y equals a negative 2/5. So I see fractions. I do not want to deal with fractions. I've had enough of fractions for the day. Thank you very much. So I am going to, first of all, look and see how many chunks I've got going on. So there's my division line. I shouldn't say division. That's the fence. Okay, that's where my equal sign is. So I've got 1, 2, 3 chunks. Now I could just add the 3/4 over, get a common denominator, and be done. But I want to kill the fractions. So if I needed a common denominator, what would it be? I got a 4 and a 5, so my common denominator would be 20. So I'm going to distribute 20 to all 3 of those chunks that I saw a while ago. So that's going to give me a negative 3/4 times 20 plus 20 times y equals a negative 2/5 times 20. And the reason we're doing that is because it's going to make all the fractions disappear. So what have we got now? Make sure you take it to all 3 terms. Don't forget about him. So 4 goes into 25 times. 5 times negative 3 is negative 15. Plus 20y equals 5 goes into 24 times negative 2 is negative 8. And now I'm in a situation where I've got my y's already isolated on the left. There's no y's over here. So I'm going to keep my y's on the left, and I'm going to kick over everything else. So I'm going to add 15 to both sides. So 20y is positive 7. And then how is the 20 connected to the y? It's connected through multiplication, so I divide. So my answer is right here. I just need to see if it's reducible, and it's not. So my final answer is 7/20. All right, let's do one more. So I've got a 6 times a negative 3x plus 1. And that's going to equal a negative 17 times x plus 1. So I'm glad I'm not in fraction world. That's fine. But I don't have just a variable term plus or minus a number equals a variable term plus or minus a number. So what's something I know how to do? Well, there's nothing to be done inside either set of parentheses, but I can distribute. So I'm going to distribute that 6 to both of these, only to the term that he belongs to. So that gives me a negative 18x plus 6. And I'm going to distribute this negative 17 to the terms that he belongs to. So it gives me a negative 17x minus 17. So now I've got variables plus or minus numbers equals variables plus or minus numbers. So I want to move the smaller set. Okay, so what's smaller, negative 18 or negative 17? Negative 18 is further away from 0 to the left on the number line. It really doesn't matter which ones you move. You'll get the same answer I do. But I like moving the smaller ones just to keep things positive. So if I add 18x's to both sides, notice that the only time we're dividing is that last step. Okay? That gives me 6 equals 18x's minus 17x's is 1x minus 17. And now I've got this positive x. That's just one way to keep me from screwing anything up. And that's why I move the smaller x's to force it to be positive. So now I've got my x's on the right, so let's kill that negative 17. So I'm going to add 17 to both sides. So that gives me 23 equals x. So I've got a single solution, and it is 23.